occurring at the coast. And forced regression, it is another term, it is the movement of shoreline seaward as the result of relative sea level fall. So you see, one is regression, which is due to movement of shoreline as a result of sedimentation. On the other hand, it is due to the forced regression, it is due to the relative sea level fall, whether it is due to tectonic or due to uh, less in volume of water or more freezing of rain or water. The sedimentary response to these changes in shoreline can be preserved in strata as changes in facies going up through a succession, changes that reflect either a landward movement of the shoreline, transversion, or seaward movement of shoreline, which is called regression, or it may be forced regression due to sea level fall or relative sea level fall. Under conditions of transgression, the shoreline moves landwards, and a pattern of changes in phases from shallow water to deeper water will be seen all across the shelf. So all these changes occur in the shelf area, not in the deep sea, because continuous sedimentation is going on in that area. But with the shoreline changes, the sediments pattern or the sediment type is changed in the same space with changes in the depth of water or uh, supply of sediments of different types in that part of the space. In case of regression, the pattern seen on vertical succession will be the opposite as the sea becomes shallower, either due to relative sea level fall or forced regression or addition of more sediment regression. The deep water faces will be overlain by shallow water faces. That means finer grains will be overlain by coarser grains. But whenever the sea is transverse, then the uh, coarser grains will be overlain by finer grains. So that is what is the key point to separate whether it is due to transgression, this deposition is due to transgression or it's due to the regression. By seeing the package of sediments in a vertical column and by following the grain size as well as the type of sediments, you can separate whether it is due to rise of sea level or the movement of sea towards land, or it is due to the movement of sea towards sea, where regression is followed. And here you can see the pattern of sedimentation in different stages. Transgression, when the sea is moving towards land. And here you can see the vertical column of sediments. So in case of, you see this is the figure showing the initial stage, and then you can see the sea is moving up towards land, and the uh, pattern of sediments changes with shift of shoreline. And here you can see uh, the uh, vertical position of sediments is changing, and as well as lateral position is also changing, and ultimately it makes a vertical column. So if you see that the uh, in the coast, the coarser grains are overlain by finer grains, or the shallower water deposits are overlain by deeper water deposits, and it is followed throughout the coast. Here you can see the shore face deposits, and there it is overlain by offshore transition deposits. And in the offshore area, offshore transition, and it is ultimately uh, by deeper water offshore deposits overlain on the offshore transition. So these are some of the phases changes, and phases deepen up. And these are the characters which can be applied to uh, to relate the shoreline change or the uh, sea, uh, whether the sea is transgressing or the sea is regressing. So in case of fall of sea level, the so in case of sea level fall, due to either forced regression or the sediment pattern is retrogradational and may include erosion surface. So sea level is falling, and here you can see the changes which may occur due to movement of sea towards sea. And here you can see the pattern of sedimentation or the vertical column of sediments. What is here? The shore face deposits are overlain by foreshore deposits. That means finer grains are overlain by coarser grains. And ultimately, there might have some erosion when the falling rate is higher than the sedimentation rate. And in the middle part, in the transitional part, you can see these offshore deposits are overlain by shore face and overlain by the coastal deposits. And there might have some erosion again. But here you cannot find the erosion because this is below the erosional level of occurrence. And here again, offshore deposits are overlain by offshore transition, and shore has some textural change in the uh, grains as well as in the rock types. Now we may see the concept of uh, space of or the how the sediments will be accumulated. For that, we need some space, and how to create this space when sea is uh, either moving towards sea or it is moving towards land, and there is as well as there is a supply of sediments. So again, it is related with the relative proportion of sea level rise or fall and the sediment supply rate. And depending on that, the uh, vertical column of rocks will be changed. So sediment will be accumulated in places where there is a space available to accumulate materials. And this space is actually created by sea level rise. When sea level is rising, you have more space to accumulate materials when there is supply of sediment. This is the concept of accommodation space, and its availability is determined by the change of relative sea level occurs. In shallow marine environments, an increase in relative sea level creates accumulation that is then filled up by sediments until an equilibrium profile is reached. That means when there is no more space. The equilibrium profile is at different positions relative to sea level in different environments. In the foreshore, it is sea level, foreshore, close to the coast. In the shore face, a few meters below sea level, and then progressively deeper through further offshore. So this equilibrium is not in the same position, but it changes with uh, uh, position depending on the whether you are in shore face, transition zone, or in the offshore zone. So the higher the rise of sea level, the more is the possibility of uh, accumulation of sediment because it will create more space or um, this accommodation space to accumulate sediments, or you can give more space for the sediments to come and deposit. And if the sea level rise is relatively less compared to the sediment supply, then there might have not only the creation of more accommodation space, but the sea may retreat towards sea because the accommodation is not available, but the sediment supply is more, and they will be accumulated in the shore, and the shoreline will be moving towards sea, though sea level is rising. So this is important because you have to consider the uh, relative rise of sea level and the rate of sediment supply. Depending on that, the space may be created for uh, deposition of sediment, or it may generate the shoreline to move towards sea if the supply of sediment is more than the sea level rise. Now the rate of change of sea level and the uh, accommodation space, what it might be. The change in the shoreline position is commenced by the relative sea level change and rate of sedimentation. If the rate of sediment supply is greater than the relative sea level rising, the shoreline will move seawards. If the sediment supply and the sea level rising are in balance, the shoreline position does not change. That means the shoreline will remain in its position, though the sea level is rising, but supply of sediments in such a position that it covers that area and no rise you can see. And the uh, aggradation is occurring. That means the same type of rock will be followed by the same type of rock. You will not find any change in the faces. The same faces will be vertically found. So this is again important to identify the relative sea level change and the sediment supply and the facies change vertically. So please wait a bit. So sea level rise give rise to different stratal geometries depending on situations. So that means the sequence which will be formed depends on the sea level rise and the rate of sediment supply. If the sediment supply is very low, then the shoreline will move landward without deposition, occurring with possibility of erosion. So in that case, we may find though the sea level is rising and the sediment supply is very low, and the in the shore near shore area there might have some erosion because sediment is very low and they will be cut. The uh, materials will be created from those areas. With moderate sedimentation rates, with high rates of rise, deposition will occur as the shoreline moves landward. Again, transgression is there, and sedimentation rate is moderate, and we may find the facies which we have seen before. That means uh, the shallow water facies will be overlain by deep water facies in this case. If sedimentation rate is higher, then the space will be filled up with sediments. Again, we will see similar type of pattern of sedimentation. At high sedimentation rate, the shoreline will still move seawards, even though the sea level rising. So you see, complication is arising. Sea level is rising, it should move towards land, but as the sediment supply is more, it is not even moving towards land, but it is moving towards sea. So it is a gravitational pattern. So if the sea level is static, the addition of sediments causes the shoreline to shift seawards. The level, if the sea level is static, but addition of sediments, as no space is created, because the sea level is not rising, though no accumulation space is there. Whatever the sediment supply is there, it will follow the same uh, coastal area, and it will shift the shoreline towards the sea. At low rates of sea level fall or high rates of sediment supply, deposition occurs as the shoreline moves seawards again. And if the rate of sea level fall is relatively high and sedimentation is low, again there might have some erosion. A coast undergoing rapid erosion during sea level fall could fall under this category. So that means when sea level is falling very quickly or rapidly and sediment supply is not so much, and then in that case we may find some erosion in the coastline or in the shoreline. And all these dictates the to identify whether you are um, uh, finding the sediment supply is more than the uh, rising of sea level, or the sediment supply is less than the falling of sea level, or whether it is in balance.
Hello, hello, sir. Hello,
Hello?
hello, sir. I have one question in
Yeah,
the
please.
previous slide.
Yeah, please.
So, will you please elaborate this situation number 5?
If the sea level is static, that means sea level doesn't change.
Yes,
The addition of sediments. So more sediments are coming, and where
yes,
they will pile up? They will pile up at the same area because
yes.
no accommodation is there, and the shoreline will move towards the sea.
So, like, if the sediment accumulated on that area, then the sea level breeze, then shoreline must shift towards the land. No, sir,
No, because the sediments are
because when the
piling up
sediment
at
accumulated
the,
on the sorry, sir, sorry, when the sediment accumulated on the sea basin is high, then the
not
accumulation
in the
space of
sea
the sea,
basin, but in the shoreline, along the shoreline, along the coast.
then it will decrease the accommodation space of the sea or increase the accommodation space of sea.
It will decrease,
When the accommodation is
but not at the basinal area. It is at the coastal part or shelfal part.
then when the accommodation space of the sea decreases, then the shoreline must shift toward the landwards. No, sir.
Not landwards. It is towards the sea, because the sediment is uh, piling up, or it is filling this area of the coast, and
So,
it will move laterally towards the sea. Laterally.
that really it was. Sir, will you please elaborate by making some figures?
By you can see all these. There are some figures
सन्जु
afterwards.
भाइ
Azure.
यो अलिकति पछि क्वेसन एन्सर डिस्कसन गरौँ न। यहाँ चाहिँ त्यही सी लेभल स्ट्याटिक भएर सेडिमेन्ट थपिँदै जाँदाखेरि त्यो सीतिर चाहिँ सेडिमेन्ट पुग्छ भनेको हो होइन, अरू चाहिँ के भने होइन, अलिक पछि चाहिँ
अनि
सरी
सोर लाइन चाहिँ सिफ्ट हुन्छ सीतिर भन्ने कुरा आयो।
हो।
सोर लाइन त सीतिर त सेडिमेन्ट त तल गइसकेपछि त सोर लाइन त ल्यान्डतिर चाहिँ सिफ्ट हुनुपर्ने जस्तो लाग्यो कि मलाई। अनि त्यही भएर चाहिँ हुन्छ हुन्छ
पछि
हस् हस्
डिस्कसन
हस्
गरौँ।
हुन्छ हस्।
ओके सर, यु क्यान कन्टिन्यू नाउ। We will
We'll
have
see some of
discussed
the
later.
figures. You see some of the figures how it moves towards the sea, because the filling of the materials uh, actually occurs along this coastal or shelfal part. And as it is filled up by materials, the shore line will shift towards sea, not towards land.
Okay, sir. Thank you, sir. Okay.
Okay, we'll see some of the figures are there afterwards. So if the coastline stays in the same position uh, and relative sea level rise occurs and sediment supply uh, procured, and the pattern of sedimentation is actually aggradation. And you can see here what happens when the shoreline is constant and the uh, accumulation space is filled up because the sea level is rising and the equal amount of sediment is coming and filling the space. So what will happen? The, there will be no lateral change in the type of sediment in the same space, and it will only grow vertically. And as a result, you can see the same materials are piling up in the same area. So when there is a balance in the supply of sediment and the rise of sea level. So this is the case. So you see same faces is followed vertically without any change in the type of rocks in vertical direction. Faces is constant. It's clear. Hello.
Yeah, sir. Yeah.
Yeah. Now we'll again clarify some of the term progradation, aggradation, and retrogradation. And here, accept the position of shoreline related to sea level change. Another way of looking is to consider arrangement of strata deposited during sea level rise, fall, or standstill. And this is what we use to relate the, uh, the pattern of sedimentation with the shoreline change. Actually, we cannot see the shoreline in the past, but whatever remains, it is the vertical column of rocks or the facies change. And this facies change will dictate whether the shoreline is progressing or it is moving towards land or it is moving towards sea or it was standstill, and what is the rate of sediment supply and the sea level rise or fall. All these can be seen from the facies. So, uh, and to look at the relative position in time and space of the facies within those strata. So the rate of creation of accommodation and rate of sediment supply is exactly balanced. We have seen this type of situation or scenario. The sediments in all environments will simply build up without any variation in facies. Foreshore facies will be overlain by foreshore deposits, shore face sediments by shore face sediments, and so on. This type of deposition may be referred to as aggradation. So this, when there is no change vertically of faces, that type of pattern is called aggradation. Shoreline that receives sediments at higher rate than accommodation creates a build out through time with foreshore deposits on top of shore face. Again, the question that you have asked, that the sea shallow water, deep water faces will be overlain by shallow water faces with foreshore for shore deposits on top of shore face deposits, which in turn underlain by offshore transition faces, and so on. This pattern of shallowing up of the faces through the succession is called progradation. And where there is a high rate of creation of accumulation compared to sediment supply, the pattern is deeper deposits will overlie the shallower deposits, finer upward or fining upward sequence. The previous case is coarsening upward sequence. And this fining upward sequence is called retrogradation. So these are three terms which are used. Aggradation, when there is no vertical change, when there is a balance in the sediment supply and the sea level rise, and progradation, where sediment supply is more than accumulation creates by sea level rising, but still the sea is moving towards sea, following the the uh, deeper faces overlain by shallower faces. And retrogradation, where the accommodation space is much more compared to the supply of sediment, and in that case, deeper deposits will overlie the shallower deposits, which is fining up sequence. So these are the three patterns which give you some idea about the change of shoreline. But still there might have some questions related. So here you can see all these figures, how it happens. And the question that you have asked, you can see it here again. So retrogradation is the uh, sequence here. You can see uh, the uh, shallow water deposits are overlain by deep water deposits, deepening up, retrogradation. Sea level is rising and moving towards the land. And as the water depth increases, gradually the finer grains will be overlain by, will be underlain by coarser deposits. Or the coarser deposits will be at the bottom and the finer will be at the top. And here, where accretion is a high sediment supply relative to sea level change. And what happens, you see it's the constant phases or there is no change in the phases. So we call it aggradation, when there is a balance in the sediment supply and in the uh, uh, rise of sea level. And here you can see aggradation and progradation. And here you can see the finer grains are overlain by coarser grains, but in the middle part, the same type of deposits are followed. This is actually aggradation. And afterwards, there might have some uh, uh, shallower deposits at the top. And when the sea is retreating, it is moving seaward, then we can get similar type of phases. And here it is called progradation, and you can see the deep water phases is overlain by shallow water phases, and the water depth is decreasing, shallowing up. And in the case 6, forced regression, when the sediment supply is not so much, but the sea level is falling. And you can see here the again the deep water phases is overlain by shallow water phases. And in case of when there is no sediment supply at all, but the sea is retreating very quickly, there might have some similar erosional feature that might be found in this case. So the question about how the sea is moving towards sea when sea level is rising, but sediment supply is much more. You can see here, so the sediment is adding here, and the shoreline is moving away from the previous position. The shoreline is moving towards sea. The question that some one of you have asked.
Yes, sir, I got it. I got it, sir.
Yeah.
Thank you.
Now the cycles of sea level changes. So you see, sea level fall and rise is related with the climatic change and the temperature of the surface of the earth. And whenever sea is uh, rising up, mostly it is due to the, if you consider eustatic sea level, that is due to the melting of ice in the polar region, and the volume of water increases, and as a result, sea level rises. And when the uh, earth becomes cool, the accumulation of ice becomes higher, and the volume of water in the sea becomes less, and the sea level is falling. And these fall and rise, actually they follow some cycles. And these sea level cycles or cycles of sea level change is also related with the pattern of sedimentation or the phases change. And those phases change that we can see in the uh, rock sequence, that dictates or that leads you to the uh, indication about the uh, shoreline change or the sea level changes. And also the uh, sediment type, which is deposited at different space along the shelf, is also related with the uh, shoreline, and which is also related with the sea level. So if you have the local sea level change, uh, this curve, you can match these uh, sedimentation time or the uh, phases, and you can see in which stage of sea level the sediments were deposited. And if they are During the rising of sea level, where the deepening of water is occurring, you may find finer grains. But whenever the sea level is falling, there is a possibility of occurrence of coarser grains, and those coarser materials may act as uh, reservoir rock, where there might have some occurrences of hydrocarbon. And that is why this sequence stratigraphy is important in aspect of uh, petroleum geology or hydrocarbon geology. So the periods of alternating sea level rise and fall can be represented by sinusoidal curve that shows the change in accommodation through time, because accommodation creates by sea level rise, and whenever it falls, the accommodation space becomes less and less, and the sea level moves towards sea with the sediment supply. The different stratal geometries can be related to the sea level change curve. Two cases can be considered depending on whether the sediment supply is relatively high or relatively low compared with the change of accommodation. Number one, with a high sediment supply rate, deposition may occur throughout the cycle, with stratal geometry 2 deposited during transgression, geometries 3 and 4 forming as the sea level rises, slows down and stops, 5 followed by geometry 6 as relative sea level falls. These 1, 2, 3, 4, 5, 6 we have seen in the previous figure, where you can see the sea level rise and fall in the rightward and leftward directions, and in that figure in the central part, and the stratal positions uh, in different scenarios. Under conditions of low sediment supply and or rapid changes in sea level, erosion may occur during sea level fall, geometry 7, and there can also be situations where erosion can occur during transgression, where the rise of sea level is very quick, rapid, and not enough sediment supply is there. The shape of the sea level curve shows that the base of the second cycle is at higher level than the first, indicating an increase in amount of accommodation through time. So you can see it here. So this is the sea level curve, and you can see different periods or different levels of sea level, and uh, and you can see the accommodation space. So whenever sea is rising or sea level is rising, the accommodation space is creating. But whenever it is falling, the accommodation space uh, reduces, and whenever there are sediment supply, the shoreline moves seaward in that situation. So sea level rise and then sea level fall. Again, there's sea level rise, and you can see the uh, sea level, high sea level, and the space of uh, accommodation is much more in that case when the high sea level, and sea level fall. Again, you can see there is no even any space in the last period of sea level rise, because they are below this level of the previous cycle. So this space and the sediment supply is also related with whether the shoreline will move towards sea or it will move towards land. So when there is no space but sediment supply is there, the sediment will pile up along the shoreline, and it will laterally move towards sea, and the distance will be increased from the specific point with time. And also the uh, deposition pattern also will be changed along with it. The depositional sequences most commonly found depending on the rates of sea level rise and fall, changes in sediment supply, and the shape on bathymetry of the shelf are: number one, a continental margin with distinct shelf break. Sediment supply is assumed to be constant, and the sea level fall to below the edge of the shelf so that there is erosion on the shelf during sea level fall. Beyond the edge of this shelf, there is a slope and a deeper basin area that receives sediments certain stages of the sea level cycle. So you see, uh, we know that most of the sediments are piled up along the coast, near shore, transition or offshore. But in the deep sea, sediment supply is much less. But whenever the sea level is falling towards certain level, then some of the sediments also reach to the deeper part of the basin. A continental shelf that is sloping ramp with no distinct change in slope. So there is no such increase in the slope. The sediment supply is again considered to be constant and is relatively high, such that deposition occurs throughout the cycle. A deeper basin area may exist, but is not strongly influenced by sea level fluctuations on the rim. So you see, uh, deeper part of the sea doesn't change with the change in shoreline so much because continuous, very small amount of sediment is depositing in the deeper part of the basin. And whenever we see this unconformity in the shelfal part, that unconformity doesn't continue in the deeper part of the basin because there is always sediment to be deposited, but their rate is very slow. So here you can see shelf break margin and the sediment supply. And you can see whole geomorphological breakdown of the this from the coast to the uh, basinal part. So here the shelf is not so big, or it is not so wider, and some of the sediments may go to the uh, slope part as well, and the deeper part is doesn't so much changed with this sedimentation. And in case of ramp margin, high sea level and low sea level, this is actually the uh, sea level fluctuation area, the uh, shoreline fluctuation area. And then you can see there is no such change in the slope, almost with gentle slope. It continues this shelfal part is very wide, and most of the sediments remains in this part. Now high stand, when the sea level is at the peak, and we call this different types of tract, system tract, depending on uh, uh, the shoreline position, where it is standing, whether it is at the peak position or at the lowest position or is uh, in the intermediate position. High stand system tract. The high stand system tract is the period of high sea level during the cycle, and the beds deposited this period are called high stand system tract. And it is symbolized as HST. So what will be the sequence there? when the sea is at the highest peak, and it continues for time. So you will find at the top of the sequence this similar type of deposits growing vertically up with huge thickness. The beds show either an aggradational or a progradational pattern as the shoreline shifts seawards across the shelf. Sediment is supplied by the rivers from the hinterland, and most of the sediments accumulate on the shelf with a little sediment reaching to the deeper basin. I stand. That means after that what will happen? It will gradually fall, or the shoreline will move towards the sea. Now the sequence boundary SB. During the sea level fall, erosion of the shelf occurs as rivers erode into the sediment deposited during the previous cycles. Where erosion is localized, the river cut incised valleys. This erosion creates an unconformity which demarcates the sequence boundary. So you see the unconformity surface. So it is sequence demarcated by unconformity and is denoted by SB, sequence boundary. And similar two unconformities, upper and lower, and the sediments within it, which we call sequence. And this sequence actually reflects some uh, time of deposition of the material within this sequence, which is bounded by the upper uh, unconformity surface and the lower unconformity surface. And these all deposits up to the slope have been deposited almost at the uh, time of that window, or uh, this uh, this sequence is within some time window, but it is not very accurate indicating the time, but it gives some range of time within which the deposition has occurred. And by that way, you can relate it with the chronologic, uh, uh, the, this um, stratigraphy. It marks the end of the previous depositional sequence and the start of a new one. So this is indicative that unconformity surface, it relates with the end of one cycle and the starting of another cycle. So there is no unconformity within the basin floor succession. That means deeper part of the basin, continuous sediment supply is there, but with very low rate. So there is no unconformity within the basin floor succession to mark the sequence boundary. So to start the next sequence is marked by correlative conformity. That means unconformity which we can follow in the basinal part, but that is not actually unconformity. That is conformity without time gap, because continuous deposition occurs in the deeper part of the basin. A surface laterally equivalent to the unconformity that forms the sequence boundary on the shelfal part only. That means whatever we see unconformity, they are not found at the deep sea. Only sea level change uh, influences the deposition at the shelfal part, not at the deeper part. And these sequences or this phases change only we will find in the shelfal part. not in the deeper part of the basin. There will be similar type of depositions with very thin laminations or thin beds. So you can see here high stand system tract, and most of the sediment deposition on shelf, and pelagic or hemipelagic deposits occur in the deep water, which is continuous. And falling stage from the high stand, when we are uh, following uh, the shifting of shoreline towards the sea. Gradually, sea level is falling from its peak position. And here you can see uh, the coast has been shifted almost close to the slope, continental slope. And most of the sediments are flushing to the uh, deeper part, including submarine fan in deep water. And maybe you know that we have in Bangladesh a deep water fan we call Bengal Deep Sea Fan. And there are some canyons along which the sediments are moving towards this deep sea. And it's forming about 1000 kilometer by 3000 kilometer area of sediment deposition. Then low stand system tract. The interval of sea level is a low stand, and the deposits of this period are called the low stand system tract. Sediments accumulation continues to occur on the basin floor fan as turbidites. Sediments may also accumulate at the base slope, forming a low stand wedge. And then transversive surface, the point at which the rate of creation of accumulation due to relative sea level rise exceeds the sediment supply to fill the space, is called the transversive surface, TS. It marks the start of a retrogradational pattern within the sedimentary succession. That means shallow water phases will be followed or overlain by deep water phases. And then there is another term which is called maximum flooding surface. As the rate of sea level rise slows down, the depositional system reaches the point where the accumulation is balanced by sediment supply. And when this happens, transgression ceases and the shoreline initially remains static and then start to move seawards. This point of farthest landward extent of the shoreline is called the maximum flooding surface, MFS. It is not the highest level in the cycle, which occurs later in high stand system tract. So here again you can see there might have some balance in the supply of sediment and the sea level rise. And the similar phases will follow. That means the deep water phases will be followed by deep water, and shallow water phases will be followed by shallow water. And you can see again low stand system tract, and as you have seen in this previous slide, um, the most of the sediment will be supplied to the uh, basinal part, making some deep water uh, uh, this isolated areas where the deposition will occur, but they will be reduced with time. Now again the transversive system tract, when again the sea level gradually rises, creating some more space to accommodate the sediments. And as a result, we will get phases of shallower water phases will be followed by deep water phases. And the sediment supply will be accommodated in the shelfal part mostly, with some of them in the slope part. And in the deep water, pelagic sediments will be deposited, very fine grain deposits. Now you can see here the last slide, the different system tracts. And here you can see the uh, when the uh, transgressive, regressive, or aggradation, progradation, or retrogradation deposition occurs in different stages of system tracts. And you can see the maximum flooding surface when the sea is at the peak of its rising level, and then it starts to gradually falling. And you can see uh, the sediments uh, depositional pattern here. And in transgressive system tract, when sea level is gradually increasing, but at the maximum flooding surface, it is the peak, and then it starts to fall again.
Excuse me, sir.
And you can also see the sequence boundary, which is
Excuse me, sir.
an unconformity surface. And that unconformity surface relates the beginning of another cycle and the end of the previous cycle. And when this unconformity surface, you see there might have some erosional features also. And this erosional surface may be filled up by different types of deposits. And it can be uh, indicated whether this occurred during the sea level fall or sea level rise. And depending on that, you can differentiate whether the sediments will be finer grain or coarser grains. So that is all about. So that is about this lecture today. If you have more things to discuss, we can discuss a bit for 5 to 10 minutes.
Thank you, sir. If anyone has any questions to ask, you may proceed.
So I will send you this lecture, and if you are interested, you can go through. And if you find that um, there are some things which are not very clear to you, we may have some time in future to discuss all about.
Yes, sir. Thank you, sir. Now I would like Mr. Pawan Kumar Acharya to end this program.
Pavan Kumar, please unmute.
Okay. Thank you, Mr. Vivek Gimire, Secretary of this society, and I would also like to thank presenters Professor Dr. A.S.M. Woobaidullah for your wonderful presentations and providing us your valuable time to valuable time. I also want to thank the executives of this society, former President Mr. Krishna Prasad Kafle, Nepal Geological Society at the Executive Committee, and all participants from national and international level as well. Uh, as we know, the sequence stratigraphy is a newly designed course in MSc General Geology, and in Nepal we have many sequence is marine deposits, and we found that there are many scopes in our nation as well. But the major problem is that the lithostratigraphy is not well established in our country, and we need extensive research and investigation on these subjects in current situation. Obviously, we believe that presentation of Professor Ubaidullah provide insight to students and other participants who want to learn about sequence stratigraphy. Uh, if we found appropriate time and conditions, we will certainly request professors for the presentations on interrelated topic and also in geophysics, which is his main expertise. At last, I want to thank you all for your gracious presence in this program. Hope to meet you next time. Now, I announce the completion of this program, and we want to close this program now. Thank you all. And if our presenters, professors have any things to say, then he can.
Yeah. Okay. Thank you, Mr. Pavan Kumar Acharya. I'm very grateful to you and the participants who are listening me with patience. I know it is not so, maybe it is not so clear to all of you, but if you go through it uh, line by line, and I think it will be much easier because I am telling you in quick time and to uh, realize all the things together, not so easy. But if you read it with taking time and you think about this, things will be much more easy to understand. So I hope that the materials I am going to send you will clarify the things that are not very clear from my lecture, from my this delivery. But with this lecture going through, the things will be clear more to you. Thank you all for your patience hearing and hope to meet you in future. Thank you. Thank you very much.
Yeah, thank you, sir.
Thank you, sir.
Okay.